Hey, I'm doing something a little different today. What I wanted to do was derive the half angle formula for tangent, and I wanted to derive both these formulas, although these two versions are very similar, not hard to show the difference between these two. And we also want to derive it in both directions, so that means I want to show we could just use this piece and we could, from this point, derive tan x over 2. And then the other way, take tan x over 2 and derive one of these formulas. Okay, so let's get started with this now. So what we're going to do, the good thing about deriving any of the half angle formulas is it's pretty easy because we just make use of what we know from double angle formulas and we kind of reverse them. So we have these over here on the right, and what I want to start with is what we'll do is we'll take this and we're going to go in this direction and try to show that this equals tan of x over 2. And what I'm going to do is we'll have our 1 minus cos x over sine x. So what we can do is just a slight manipulation of these first two formulas, and wherever we see an x, we'll use an x over 2 in order to get this in a different form. So if we put an x over 2 in for sine of 2x, we're going to have sine of x equals 2 sine x over 2 cos x over 2. And then similarly for the cosine one, if we put a x over 2 in there, we're going to have cosine of x equals 1 minus 2 sine squared x over 2. And then we're going to use that in this expression, so we're just going to plug in what we found here. So we're going to have 1 minus, for cosine x, we're going to have 1 minus 2 sine squared x over 2. And then for sine x, we're going to have this thing over here. Then simplifying, when we distribute in this minus sign, this 1 minus 1 0, and then this is going to be a plus 2 sine squared x over 2. And then in our denominator, we're going to have 2 sine x over 2 cos x over 2. Our 2's are going to cancel. One sine is going to cancel here, and we just have sine over cosine, so that's going to be tan of x over 2. Okay, so pretty easy to show that in this direction. These are equal. Okay, so now let's just show this in the other direction, starting with our tan x over 2. Tan, of course, is sine over cosine, so we'll rewrite this as sine of x over 2 over cosine x over 2. And now, similar to what we did over here, we want to do something to get a value for sine x over 2 and cosine x over 2. Okay, so I corrected my original formula. I had this double angle formula wrong. This is a 2x for this in each of these cases here. So then coming down here, you see we did the same thing where we replaced wherever we saw an x, we replaced it with an x over 2. And so we reduced the angles here and here and here. And then we just took a square root on both sides. Okay, so by taking a square root, we had to have this plus or minus here. And so here's our half angle formula for sine and cosine. Okay, so now I've just plugged in each of these values that we found here in our expression where we're trying to derive from tan x over 2. And then at this point, you can see what we can do is we can take this, now we have a square root in the numerator and denominator, so we can make this 1 square root, and we can cancel these 1/2. And then also with the plus minus, what we'll do is we'll just have 1 plus minus. So let's rewrite this. And then from here, I'm going to just use the conjugate, and we'll multiply a 1 minus cos x on our numerator and denominator. So we're going to have plus minus 1 minus cos x squared. And then we multiply this up, we're going to have 1 minus cos squared x. But this piece we can rewrite as just sine squared x. And at this point, we can cancel these squares with the square root, but we need to be a little careful because we actually need absolute value signs, or at first, let's have absolute value signs because we want to make sure that we're not losing any negative values here. So we know that sine has some negative values, we would lose those if we just would remove the absolute value sign. So for now, we need to leave the absolute value on our sine expression. In the numerator, however, though, this piece is always positive. You notice cosine can never be greater than 1. And if its cosine's negative, this is definitely positive, but the most cosine can be in the real world is 1, and so this would be 0, so we can just remove absolute value signs here. Okay, and here's the part where I didn't find a good explanation, because we have this plus minus, we have these absolute value signs, and then you see in the formula that we have everywhere, like this, we have neither of those things, so we still have a little bit to overcome. So we already showed in the first part that this piece is true, so we need some way to get rid of our absolute value sign, our absolute value and our plus minus here. So how are we going to do that? This plus or minus sign right here comes from whatever quadrant the half angle is in, based on what the sign of tan is, which we know that tan is positive in quadrants 1 and 3, negative in quadrants 2 and 4. And then also we need to know what is sine in the different quadrants. So we actually know all those things. We just kind of need to look at it case by case. Okay, so then I've done a table with each of the 4 cases with the 4 quadrants here. So like if our half angle, or x over 2, when we're in quadrant 1, that's between 0 and 90 degrees. In quadrant 1, at that place, tan of x over 2 is positive. To get our x, we double this. So if we double 0 to 90, we're looking at 0 to 180. That's the top, the whole quadrant 1 and 2. I should write that. This is 1 and 2. And then in that region, sine is always positive. So if we have positive, so we're saying here we're going to use our positive sign. And then if sine is positive, we drop the absolute value. So we just get the formula that we know. Then in quadrant 2, that's from 90 degrees to 180 degrees. Okay, so in that quadrant, tan is going to be negative. We double 90 to 180, we get 180 to 360. So that's like the lower half of the unit circle. Okay, and so 180 to 360 in quadrants 3 and 4. Sine is always going to be negative. So if sine's negative, okay, on our absolute value, what we need to do is actually we need to write we can drop the absolute value, but we'll write it as a negative. We got our 1 minus cosine x. Because our tan is negative in quadrant 2, we have a negative in front, but then we can just cancel a minus and a minus a plus, and so we get our formula again. Okay, now quadrant 3 is going to work exactly like quadrant 1. Between 180 and 270, tan is positive. We double 180 to 270 and we have this range, 360 to 540. But 360 to 540 is the same thing as 0 to 180, which is quadrants 1 and 2. So sine is positive, and so we just get our formula where we drop our absolute value and we have a positive sign. And last, I think you get the feel for it, but quadrant 4, 270 and 360, tan is negative. Double it, 540 to 720 is the same thing as 180 to 360. In that region, that's the bottom half again. So sine's going to be negative. Exact same thing as we had here. We're going to have negative sine x, but the signs are going to cancel and we get our formula. So in any case we have, if there is a negative sign, the negative signs will cancel, or if there's positives, we just drop the absolute value. So we can go right to this formula. Okay, so the last thing I want to show, and this is really the easiest part, is we have these 2 different formulas for the half angle identity for tan. And I just want to show that they're the same thing. So we'll start with the left side. We have 1 minus cosine x over sine x. We can just multiply 1 plus cos x on the numerator and denominator. When we do that, the top is going to be 1 minus cosine squared x. And then I think we'll just leave it like sine x, 1 plus cos x. But this is going to be the same thing as sine squared x. So rewriting this, oh, I smudged it. This is going to be sine squared x over sine x, 1 plus cos x. That one sine cancels, and we're left, this is the same thing as our formula, 1 plus cos x, and that's what we wanted to show. Okay, so that's it, the half angle formula for tangent. Thank you for watching. Please like and subscribe, and have a great day.